Students often seek a deeper understanding of the various concepts in physics. From classical mechanics to quantum theory, it offers insights that illuminate phenomena ranging from everyday occurrences to cosmic events. Study of physics not only enhances scientific literacy, but also fosters critical thinking, enabling students to explore the captivating interplay between matter, energy, and the fundamental laws governing our reality. To explore more, please view this channel and subscribe.
Dear students, in this video, we will study about alternating current, its introduction, sinusoidal alternating voltage, mean or average value of alternating current, and also about RMS value of alternating current. Now, let us study about alternating current introduction. In the previous section, we have seen that when the orientation of the coil to the magnetic field is changed, an alternating EMF is induced, and hence an alternating current flows in the closed circuit. Now let us see what is an alternating voltage. An alternating voltage is the voltage which changes polarity at regular intervals of time, and the direction of the resulting alternating current also changes accordingly. In this figure 4.34a, we have an alternating voltage source which is connected to a resistor R, in which the upper terminal of a source is connected to the positive and the lower terminal is negative at an instant. Therefore, the current flows in clockwise direction. After a short time, the polarities of the source are reversed, so that current now flows in anti-clockwise direction as shown in 4.34b, like this. So here, the polarities are changed. This current, which flows in alternate directions in the circuit, is called alternating current. Sinusoidal alternating voltage. What is that? If the waveform of alternating voltage is a sine wave, then it is known as sinusoidal alternating voltage, and that is given by the relation V equal to Vm sin omega t. That is, V is the instantaneous value of alternating voltage, and Vm is the maximum value, that is called as amplitude, and omega is the angular frequency of the alternating voltage. And the sinusoidal alternating voltage is applied to a closed circuit. The resulting alternating current is also sinusoidal in nature, and its relation is given by I is equal to Im sin omega t. So this Im is the maximum value, which is called as amplitude of the alternating current. The direction of sinusoidal voltage or current is reversed after every half cycle, and its magnitude is also changing continuously, which is as shown in this figure 4.35. So this is a sinusoidal alternating voltage indicated by this pink color graph, and sinusoidal alternating current indicated by this blue graph. Next, we study about mean or average value of alternating current. The current and voltage in a direct current system remain constant over a period of time, so that there is no problem in specifying their magnitudes. However, an alternating current or voltage varies from time to time. Then a question arises how to express this magnitude of an alternating current or a voltage. There are many ways of expressing it, but we limit our discussion with only two ways, namely mean value and the RMS value, that is called root mean square value of alternating current. Now let us see what is mean or average value of alternating current. We have already learned that the magnitude of an alternating current in a circuit changes from one instant to other instant, and its direction also reverses for every half cycle. During the positive half cycle, current is taken as positive, and during the negative half cycle, it is negative. Therefore, the mean or average value of symmetrical alternating current over one complete cycle is 0. Therefore, the average or mean value is measured over one half of a cycle. These electrical terms, average current and average voltage, can be used both in AC and DC circuits analysis and calculations. The value of, that is the average value of an alternating current, is defined as the average of all values of current over a positive half cycle or a negative half cycle. This is how it can be defined. And the instantaneous value of sinusoidal alternating current is given by this equation: I is equal to Im sin omega t, or I is equal to Im sin theta, that is theta is equal to omega t. whose graphical representation is given in this 4.36. So this is the graphical representation of sine wave of an alternating current. So it moves like this. That is moving in the positive half cycle and the negative half cycle. The sum of all currents over a half cycle is given by area of positive half cycle or the negative half cycle. Therefore, the average value of current is given by area of positive half cycle or area of negative half cycle, that divided by the base length of half cycle. We will see what is the base length of the half cycle. So in this case, let us consider an elementary strip of thickness d theta as shown in this figure in the positive half cycle of the current wave, and let I be the mid-ordinate of that strip. So this is the value of current I. And the area of elementary strip is given by I times d theta. The area of positive half cycle is given by integral 0 to pi I d theta, that's equal to integral 0 to pi I m sin theta d theta, where I is equal to I m sin theta. So that is given by I m, taking it out and integrating the sin theta d theta, we have minus cos theta, limits 0 to pi. That's given by minus I m cos pi minus cos 0. As cos 0 is equal to 1, we have 2 times I m, substituting these values. And the base length of the half cycle is pi, and substituting these values in the equation 4.31, we have the average value of the alternating current as I average equal to 2 Im by pi. So I average is given by 0.637 times the maximum current, Im. Since the average value of AC is 0.637 times the maximum value of current Im of the alternating current, that's the average value of the alternating current. And for negative half cycle, we have Im equal to 0.637 times Im. That will give you the average value of current IAV. Next, we will study about the RMS value of alternating current. The term RMS refers to time varying sinusoidal currents and voltages, which is not used in direct current systems. The root mean square value of an alternating current is defined as the square root of the mean of the squares of all currents over one cycle. It is denoted by IRMS. For alternating voltages, the RMS value is given by VRMS, and the alternating current is given by I equal to Im sin omega t or Im sin theta, and that is represented graphically in 4.37. The corresponding squared current wave is also shown by the dotted lines in 4.37 here. So this is the I square wave, the dotted lines. And the sum of the squares of all currents over one cycle is given by the area of one cycle of squared wave. Therefore, IRMS is equal to square root of area of one cycle of squared wave by base length of one cycle. So an elementary area of thickness d theta is considered in this first half cycle of the squared current wave, as shown in this figure. And let I square be the mid-ordinate of the element, and the area of the element is given by I square d theta. Area of one cycle of squared wave is given by integral 0 to 2 pi I square d theta. This is the graph, and that is given by Im square integral of 0 to 2 pi 1 minus cos 2 theta by 2 d theta by solving this. And as sin square theta equal to 1 minus cos 2 theta by 2, we have this expression, that is Im square pi as sin 0 equal to 0. The base length of one cycle is 2 pi, that is starting from this point 0, and to complete this cycle we will have 2 pi radians. Therefore, that is called as the base length of one cycle. And substituting these values in the equation 4.33, we get this expression IRMS equal to Im by root 2 times, or IRMS equal to 0.707 times the maximum current Im. And we find that for a symmetrical sinusoidal current, RMS value of current is 70.7% of its peak value. And similarly, for alternating voltage, we have VRMS equal to 0.707 times maximum voltage Vm.